Hey guys, welcome back to my happy place. Been spending a lot of time out here in the shop, and my name's Frank, if you're new to the channel. Working on a 1972 Cub Cadet. Not so much working on the Cub Cadet as adding stuff to it. So I wanted a bush hog. I wanted a small bush hog for this tractor. This tractor has a rear PTO, which is unusual for these tractors, but this 50-year-old tractor does have a rear PTO. So I thought, what better attachment than a bush hog? So that's what I'm doing. I'm going to put a bush hog on this tractor. I'm going to build the bush hog, and in order to run the bush hog I needed a category 1 3-point hitch, and I chose to do a category 1 because then I can put on any category 1 attachment besides the bush hog, since it does have the rear PTO. And the second thing I'm adding is a hydraulic system. Since this tractor is a gear drive tractor, it doesn't have the auxiliary hydraulic ports that many of the later model hydrostatic tractors had. That they had a hydraulic lift, and you could adapt that to, you know, operate cylinders and that sort of thing. The auxiliary outputs on the hydrostatic transmissions were not high flow, like 1 GPM, and not high pressure, only about 600 PSI. So they had limited applications, but they certainly could operate hydraulic cylinders, which is what I need to do to have a lift on here. So without that hydrostatic transmission, wanting to keep the gear drive and not change the rear end or the transmission on this tractor, I've decided to add a complete hydraulic system, including a hydraulic pump, reservoir, filter, valving, necessary to operate the 3-point hitch, lift and lower the hitch. So that's where I am. We've got the lift, the 3-point hitch is finished, and we're working on the hydraulic system right now. We left off last episode with a bit of a misstep on mounting the valve, the spool valves, to operate the rear lift. I thought I had room for them in the place I decided to put them. Didn't really work out, so we left last episode with me thinking about a better solution, and I think I've come up with one, and I think it's going to be fine. It's very actually turns out to be similar to how the valves are mounted on a couple of my other builds, so it's not surprising that I went back to that mounting position. So I'll take you over to the plasma table. We'll look at the plate, the mount system that I designed in Fusion 360 and have up in fire control, ready to cut out on plasma, the CNC plasma table. So we'll cut out, first I'm going to cut out a piece of, I think it's 16 gauge, it's thin, like 16th inch sheet metal, just to make sure it's going to fit and do what I expect it to do. Then once I'm happy with it, I'm going to cut it out of 1/4 inch plate steel. And I do this, I did it for the support arms for the 3-point hitch. Whenever you've got, I mean, this plate steel can get expensive, so and of course the thicker the plate, the more expensive it is. So it's so much cheaper that it makes sense to prototype it first out of something lightweight, inexpensive, and then once you're happy with it, cut it out of the heavier metal. So that's what we're going to do. We'll make sure it fits. Now, I have used cardboard to do that, but even with cardboard, the resolution, it's making it out of cardboard and then creating the drawing out of it and that sort of thing. There's something lost in translation. So even when I've done it in cardboard, as some have called, and I love the term, someone commented, cardboard aided CAD, cardboard aided design. I've used that on many of my builds. So, but I'm going to just cut it directly out of the 16 gauge, and we'll see, make sure it fits, and then we'll cut it out of the 1/4 inch. Since the last time we were here, I've actually removed the gas tank, set it outside, and so we're going to the plasma table, cut it out, cut this test piece out, see how it works. All right, stick around. Okay, folks, here I'm in Fusion 360. This is the first valve plate that we fabricated and bent, and then decided that it probably wasn't in the right position. So I started working on another plate, and what I finally settled on is this one, which will have 2 bends in it. And we're going to cut this one out of 16 gauge and test fit it before we come back and cut it out of 1/4 inch plate. So here we are, we're in design mode. I've already extruded this. Let me show you the body. Alright, so this is the piece. This is actually extruded to 1/2 inch. It doesn't matter. The one up here is 1/4 inch. All we need is the face profile, so it doesn't matter the thickness. I think the thickness is addressed by parameters in the setup file, which is handled under the manufacturer tab. So the setup is set to the setup is set to 1/4 inch. We'll change the cut speed in fire control software. So this is the plate that we're going to cut out, and I can go into fire control, and I've already imported it into fire control here. So here it is. We're set up to cut this. The cut speed, let's see, let me set the program origin right here. Program speed is set to 40 right here, but we want that to be about twice that, so we're going to go up to 80. I normally cut 16 gauge at 85. We cut 1/4 inch at 40. Okay, so I think we're ready to cut this out. I've got the plasma table filled with water. The air system is charged, so we'll go ahead and start the program here. Alright, so we'll test fit this. Alright, so this has a clearance for the PTO clutch rod. This will be bent, and then this has clearance over the, this will be bent. So this piece will go back. So it looks like, just want to make sure the dash holes line up okay. Yeah, they look like they line up great. Okay, let's go bend this. Well, that worked pretty well. I wasn't sure how I was going to make that since I couldn't do that in the other. But that's going to create an issue when I go to do the 1/4 inch plate, because I can't do the 1/4 inch plate on here. I don't know what I'm going to do. Well, let's see if this fits. I'll have to address that. So that's another reason to do a prototype, because just getting the bends made creates a challenge. All right, well, the holes fit. But I don't see how I'm going to make the bends on the big break in 1/4 inch. That's going to be the problem. So, I mean, this is why you do a prototype. I think I'm going to a little more room here. I hate to do much more because I don't want to make this any thinner than I have to. Well, that doesn't touch if I go like that. All right. So I do have the clearances everywhere. I made these holes big enough for allow for some adjustment up and down. So I think if I go like that, I have clearance above the tank. It doesn't touch that rod. But I don't see how I'm going to do the bends on the brake. I'm going to have to weld it up. All right, so I've stacked an old milling vise on here to raise it up to get clearance. I'm going to try this. I may have to raise it up more. Well, that worked okay, I think. I overbent it a little bit, but let's see how it fits here. I think that'll fit okay. All right, so let's cut it out of 1/4 inch. See how that goes. All right, I think I've got it. I've got a pretty good bend there. I mean, it's not the greatest. You know, this is rounded off because of the notch here, but I think it's pretty close to the 90-degree bend. So let's go see how this fits. So the brackets that hold up the fuel tank mount to these 4 bolt holes as well. So we'll get that mounted. We need to then mount the valve over here. Got these 2 diagonals to weld in here to stiffen this up. Probably only need this one because this is attached to that. So the valve will mount like that. Bolt to it. All right, we'll let this cool down for a minute. Let's turn our attention to the valve here. And on these valves, you have two sets of input and output, in and out ports, and 4 working ports. So on this valve, you have an in, and then you have an out and an out. And you can take this plug out and put it over here. Actually here, not there, here. So these 2 ports are the same. You got to plug one of them. These 2 ports are the same. You got to plug one. I'm going to leave this one. I'm going to use this one, but I'm going to plug this one and use this one. That lets me get a lot closer to the dash. So I've already taken the fitting out of here. I had a fitting like this. We're going to put a similar fitting right here. We're going to take this out. All right, so these are actually 10 millimeter. Let's see if we can break this one loose. There we go. Very tight. Okay. All right, so you always got interference problems with connections to these valves. I don't know why they don't spread the... You got this whole body here. You could spread these working ports. Seems to me you could spread them apart so that you could actually turn these things around. You got to use a whole assortment of different adapters and fittings. Need to get some straight. Like here, I have these two. I have a straight one here. I need a straight one over here, and an adapter or something. Same here. I'm going to need a straight fitting. I'll look and see if I have one. I don't think I do. So I actually do have an adapter here. So that raises it up far enough to rotate like that. I have angle 1 over here, so I'm fine. This is a different size. Let's see. They're 2 different sizes. This is number 10 and number 8. Yeah, so that's... So I need a number 8 extension or adapter. All right, I have an adapter, but it's pipe thread and it's the wrong size. This is too big. This is number 10, number 10. I need a number 8, number 8 to fit one of these. Okay, so I need to make another visit to the Napa, see if I can get that fitting. Last time I tried to buy fittings, this fitting, which is $2 or $3 online at surpluscenter.com. Again, no affiliation, but I do buy a lot of stuff from them because their prices are good. The same fitting at Napa was $32. I don't know what's, I think it's got to be mispriced, because they used to be $7 or $8 or $9 for a right angle number, this is number 8, SAE O-ring number 8 to number 6 JIC male. I don't know. It doesn't make sense to me why it would be so much more. It's $2 or $3 online. Anyway, all right, so I need to get some more fittings so I can fit everything on here. And so I'll work on that. Meanwhile, let's go ahead and get this mounted. I want to touch up the valve bracket that we just finished welding up. Just want to soften, you know, all the edges that you might bump into with your hands. I'm not going to fully tighten them yet. Need to move this hole over 1/4 of an inch since this bracket moved forward 1/4 of an inch. That's good and solid. I'm pleased with that. I was concerned that it would be too flexible, but it is actually pretty sturdy. All right, now's the big test. All right, so that's good. There's my hands don't hit this. There's clearance. And there'll be room for the hoses here. It's going to be close, but not going to be a problem, I don't think. If it becomes a problem, then I can mill slots in this plate and slide this plate back. There's 1/2 inch if I need to, but I think that's going to be fine. That's a much better solution than what we had last week. Not in my way getting on and off. I think that's a good solution. Okay. We need to measure for some hoses and get some more fittings. So my method for measuring for the hoses is to take a piece of hose and run it where my hose needs to run. One right there. "26 inches was 48 plus 52 inches. Maybe they'll just run like this. All right, so I need two at this length, one at this length, one at this length. They're all pretty close. Let's measure them. Got a 58, a 62, and a 66. All right, so I'll go to Napa. I give them this diagram, and they're all female JIC number 6 swivel. So that way they know, you know, how to make the hoses. I mean, I give them a diagram and leave this with them, and I'll come back the next day and pick up the hoses. This will be 4 hoses, basically 5 feet long, almost, a little bit over. Another one almost is 4.5 feet, almost, yeah, 4.5 feet, 12 inches, and another 2-footer. So I'm going to say this will be, and I'll show you what the receipt is going to be. I'm going to say it's going to be $700. Basically $100 per hose. We'll see what comes out. All right. Hey guys, that's it for this week. I feel like I've been vindicated a little bit with my new position for the spool valves, much better, and actually it's in a very similar position to where I have previously mounted on my other project. So I should have thought of that initially, but it's okay. It looks like it's working fine. So I think that's a good solution. We'll come back next week with the hoses, hopefully. I'll take these measurements up to Napa and drop them off. It'll be a couple, 3-4 days before they get to making the hoses sometimes. And a couple more adapters. I hope they have them, because if not, I have to order them and wait for them to come. But with any luck, we'll be hooking up the hoses next time, and maybe getting the hydraulic system potentially running. Got to put the fluid in the tank. Got to figure out which side of the pump is a suction and which is the discharge. And you just can do that by, those pumps run either way. They're gear pumps, so you can run them either way. Based on the rotation this one's running right now, one side or the other could be suction and discharge, don't know. But the easy way to tell is you're running it slowly, like cranking the engine. You can put your finger over the 2 ports and you can feel the suction on one side. So you can tell which one's a suction, which one's a discharge. And so I'll do that before we hook it up. The hoses will accommodate either side. Do need a couple more fittings, like I said. We'll get the hydraulics hooked up next time. So leave a comment, tell me what you think, and subscribe if you haven't already subscribed. And a thumbs up would be great. See you guys next week.